So let's go to the second part of the chloroform, that is some properties of the chloroform. There are some properties which are very small properties, but we have to take care even such reactions also. One is a halogenation, further halogenation. In fact, halogenation of chloroform leads to give the further halogenation with the chlorine and the UV light. The another halogen will come, CCl4 is formed. This is the simple reaction. Reduction of chloroform, this is also very simple. The chloroform can be reduced with tin and HCl. However, the first you will get CH2Cl2 plus HCl. Further reduction will give CH3Cl methyl chloride plus HCl. Further reduction will give the CH4 plus HCl. So if it is continued for the 3 steps, finally methane will be formed. These two common reactions of halogen compounds. However, we have some specific reactions like one is a oxidation. Chloroform is quite a stable compound. However, when a half-filled bottle of the chloroform is kept aside, after a few days and constant exposure to the light, this common light, if the bottle is exposed to the common light, naturally inside air is there. In that air, oxygen will be there. Slowly oxidation takes place and the chloroform is oxidized with the atmospheric air. This is from air, need not to add oxygen, atmospheric. But the time will be, enough time should be there, isn't it? Not immediate reaction and slow time reaction, that is on few nights, if you days, if you keep it over like that, then the slowly reaction takes place. So you will get a dichlorocarbonyl, or it is called carbonyl chloride, or commonly known as phosgene, plus HCl is formed. As such, the reaction, the chemical part of this reaction is not that important, but when you come to the medicinal point of view, the chloroform is an anesthetic agent. In the hospitals, we use this chloroform to the patient, and it's a local total general anesthetic, unlike the local. So the patient will become unconscious and we do for the operations and all that. So there this chloroform is used for the unconscious, that is used as an anesthetic agent. But unfortunately, this chloroform, if it is kept for longer time, some of the part of the chloroform is converted to phosgene. It is a gaseous compound and it is poisonous also. So as it is the gaseous one, it is soluble, it is an organic compound, covalent compound, it is gas, all the gases are inevitably the covalent. So this is highly soluble in the chloroform. So the poisonous gas is formed, but it will be soluble in the chloroform. Such a chloroform, in fact the chloroform containing phosgene, if it is given to the patient, already he is in trouble because he is undergoing some operation. When you add this poisonous gas or the substance to the patient, it leads to the complication. Therefore, we have to check this chloroform whether this phosgene is there or not. We have a chemical test. The test is adding the silver nitrate and checking whether this the phosgene is there. You get a white silver chloride. It is unfortunately not from the phosgene, from the Cl. So the HCl reacts with the silver nitrate, gives the silver chloride. When you are testing the HCl, how can you say that this phosgene means? It is an indirect test. When phosgene is formed, definitely HCl will be formed. It's a byproduct. When HCl is there giving white color precipitate it is, that means phosgene also will be there. So you take the chloroform, add some silver nitrate, white color precipitate means the Cl is present, that is HCl is present, so indirectly phosgene is also present, isn't it? So in general what we do is we add some to this chloroform, a small quantity of ethanol is added in anticipation that a part may be oxidized. This ethyl alcohol is added to the chloroform and preserved. If at all the phosgene is formed, it reacts. this ethanol reacts and forms into a carbonate. A diethyl carbonate is formed, which is a non-poisonous. Most of the carbonates are edible, like bicarbonate and so on. So this is a diethyl carbonate, which is a non-poisonous material. So when chloroform you are storing, take one care, add little ethyl alcohol and then store it. Second one, wrap with a paper so that light will not enter. Take that chloroform in a brown colored bottom. Like that, some laboratory precautions will be there. So one of the precaution is adding some ethyl alcohol, anticipating the oxidation. So if you add ethyl alcohol, the moment phosgene is formed, it converts into a non-poisonous material, which can be safely can be used on a patient. So this is the one. This test has got now the what you call in the differentiating or identification test, like you can use it. As I said, the phosgene is a gaseous one, it is a covalent compound, right? So it is understood that covalent compounds are not going to react with the silver nitrate. So therefore I have a list of the compounds which are not going to react with silver nitrate. Though the chlorine is there, no reaction. So will the methyl chloride react directly with silver nitrate? No. Similarly, in general, all alkyl halides will not react with this reaction, okay? Specifically chlorides, okay? Then you can also go for the aromatic. Chlorobenzene will not react. Even 1 degree, 2 degree, all this will not react. Vinyl type of the halogens also will not react. Okay, these are all the reaction not going. And in addition to that, dichloro compound CH2Cl2, that is a methyl chloride, and chloroform also is not going to react. And the COCl2 phosgene, what we have examined, also not going to react. Then which compounds are going to react means HCl, specifically aqueous, is going to react. So with a silver nitrate gives a beautiful silver, and the chloride precipitate is going to come. Similarly, salts of the halogens, plus and minus aqueous solution, if you take immediate precipitation, you get the reaction. And there are some specific examples in organic chemistry, that is benzyl chloride is going to react. Why benzyl chloride is it not organic means if the Cl goes out, what you get is a benzyl carbonium ion has got resonance stability. That's why even though it is organic compound, when you add silver nitrate, that is specifically in acidic medium or in the alcoholic solution of silver nitrate, if you add to the benzyl chloride, immediate white color precipitate is formed. Even allyl type of the chlorides also will give the reaction. The allyl chloride also, if Cl goes out, you will get allyl carbocation, which has resonance stability. Even the lastly, we can also claim this type of tertiary type of the chlorides. This is 3 degree type. This is allyl type. So benzyl type, allyl type, and 3 degree halogens also are going to give the reaction. Specifically, make a point that the 3 degree gives, but slowly gives, not immediately. Benzyl and allyl immediately. All ionic the halides or HCl in the aqueous solution, all these compounds are going to give white precipitate, but not this type of the compound. So therefore, we have some questions like this. If a chlorine is attached directly to the halogen like this, okay, this compound no reaction. But the same type of the its isomer, that is a CH2Cl, this is going to react, right? So if this is a benzyl chloride, this is a paramethyl chlorobenzene. Both are isomeric to each other. To look, they are similar. Similarly, we have a question like this. We have a chlorine here, CH2 iodine here. Another compound, iodine is here and the chlorine is here. Now both are treated with the silver nitrate. In this case, the iodine is liberatable, ionizable. You will get a yellow color precipitate of silver iodide. In this case, silver nitrate reacts and you will get a silver chloride. So, if both are treated with the silver nitrate, AgNO3, in this case white color precipitate is coming, in this case iodine is coming, silver iodide comes. Silver iodide happens to be yellow color precipitate. So, you get in one case yellow precipitate, in the other both are having chlorine and the iodine and chlorine. But linkage through this is benzylic, iodine is benzylic in this case, so it is liberatable. The chlorine is benzylic, therefore that is liberatable, right. Like that concept oriented questions, differentiation question, however it is linked to this test phosgene extends or enables you to enter into this type of the differentiation type of the questions to ask. So, be careful about this question. So, the other reactions like it can be nitrated, nitration of the chloroform. Methane cannot be nitrated, but a hydrogen attached to carbon where 3 chlorines are there because of the minus I effects of this chlorine. Just with nitric acid the nitration can be done. You will get a nitrochloroform, Cl3. Nitrochloroform is specifically called chloropicrin and used in the tear gas preparation. It has got the producing the unusual the tear formation with the burning sensation and all that. Therefore, to disturb the mob, police people are using this chlorinated, nitrated, chlorinated methane. It is, isn't it? It's called a nitrochloroform or a chloropicrin under the usage. This as a tear gas it is used. Plus water is formed. This has some industrial application. The chloroform can be it adds to acetone. Acetone, on the acetone, the chloroform splits up into plus minus CH, So, Cl3 is minus, H is plus, the plus adds here, minus adds here. It is a nucleophilic addition reaction. Chloroform is being added on the acetone. Acetone is actually not having any anesthetic property, but chloroform has anesthetic property. When this is added to this one, you get a mixed type of compound, that is one part is not having an anesthetic and the other one is having anesthetic, and it is mixed with a common ordinary compound. Therefore, anesthetic property is slightly decreased, and this is called chloritone. Common name is there. You can name it as a 1, 2, 3, okay, 1, 2, 3, 1, 1, 1 trichloro 2-methyl 2-hydroxy compound propane, but or a 2-propanol, it is a 2-propanol, and it has common name is there chloritone. It is used as a hypnotic agent. Hypnotic means sleep producing without any the other problems. So, sleep producing, relaxation through sleep it is producing, therefore it is called hypnotic agent, chloritone. Hydrolysis of chloroform. With chloroform has 3 chlorines, right? These 3 chlorines can be substituted with the potassium hydroxide in aqueous solution. Boil for some time, all OHs will replace the Cl. So, initially what you will get is, you can remember, so 3 Cls will become into 3 OHs. But unfortunately, that 3 OHs on a carbon is unstable, so it leads to give the formic acid. This formic acid also, because of the basic acidic property, base is there, so it will react with the KOH, forms into HCOO minus and the K plus. A salt is formed, potassium formic acid salt, potassium formate is formed. These are all stepwise. These chlorines are substituted, eliminated water, you will get acid, reacts with KOH, forms into the potassium, salt of this is formed. So, these are all simple reactions. In fact, chloroform also react with silver metal, undergoes a coupling type of reaction with silver metal or other halogen containing compounds, also trihalo compounds with 6 silver atoms. will combine like this. It's a condensation type of Woods coupling type of reaction. So if 1,1 halogen is there, RR is formed, that's the Woods coupling reaction. 2,2 halogens are there, you take zinc, so double bond is formed. If 3,3 halogens are containing, in the answer you will get a 3 bonds, that is a triple bond. So finally what you will get is acetylene is formed. So it is a coupling type of reaction in presence of that is silver and the chloroform, or trihalomethane with silver gives this type of the triple bond formation, or a compound having at the end 3 halogens are there, you can have a chloroform and get that the last end the triple bond can be generated. So synthetically applicable reaction, but simple chloroform will give the simple acetylene formation. It is a coupling type of the reaction. In addition to this, there are 2 more reactions are there. One is a Reimer-Tiemann reaction. Reimer-Tiemann reaction. This is a very popular reaction called under the RTR, very popularly known as RTR, that is Reimer-Tiemann reaction. Basic skeleton reaction is when phenol reacts with chloroform, benzene with OH is known as phenol. A phenol reacts with chloroform CHCl3 in presence of KOH or NaOH. You can take NaOH also. Boil for some time. These two generates a species called CCl2. Dichlorocarbene is produced. That is the electrophile attacks on the phenol. Yet specifically phenol is ortho-para directing. So therefore this group attacks at ortho or para or at ortho. So leading to give the 2 ortho substituted product and the para substituted product. So you will get an aldehyde group finally. CCl2 is coming, how you got aldehyde, we will see the mechanism. But finally what you will get this one, and then even para product also you will get CHO with. But you are saying a strong base, in the strong base there will be potassium salt. Therefore what you do is you all this add and heat it once. After that you add some H plus, that is a small amount of acid. If you add, the potassium salt will go, phenol will come. Otherwise potassium salt of phenol will be there. Specifically the first compound has a special name is there called salicyl aldehyde. Salicyl aldehyde. The second one has no specific name. It can be commonly said as a parahydroxy benzaldehyde or paraformyl containing phenol. Either way you can say. And the first one, this ortho isomer, specifically called salicyl aldehyde. It has 1 or 2 points. Other additional points is generally the OH is a plus M group. Therefore ortho-para directing, that's why ortho-para will come. A very small quantity of para, meta also may be formed, but all practical purpose it can be neglected. So mixture of ortho and para will be obtained. We have one point here. This mixture, if you distill it, the boiling point is very small difference will be there, both will come at a time. So therefore ordinary distillation will not work out here. So you have one specific method. What is that? Use the steam. So don't heat this mixture directly. Instead you take water and separately a flask, then heat the water, steam is coming. That steam you send into the flask which contains ortho and the para isomers. Steam specifically at 100 degrees only it will be transferred from the water to this. That means to this mixture you are 100 degrees centigrade exactly you are giving. Fortunately the salicyl aldehyde has got some that is boiling point which is very slightly little below the 100. So salicyl aldehyde alone is coming and the para is not there. We have observed that this can make an intermolecular hydrogen bonding. When this makes with neighboring molecules n number, this is it's not neighboring. So n minus 1 neighboring connections this makes, n number it makes. Therefore a slight marginal decrease or increase will be there in the second product. Therefore we are unable to separate through by sending the steam. This is called steam distillation. So steam distillation will give first a ortho isomer only, not the para one. So you can separate this salicylaldehyde and its isomer. Though mixture is coming, one can separate this mixture specifically using steam distillation. The point is that because it is orthoisomer has got a intermolecular hydrogen bonding, it makes with neighboring molecules n-1 that is connections with the neighboring. This is with neighboring n connections n-1. So when compared with that, it has less connections with the neighboring. So therefore it comes, it so happened at less than the boiling point of water. Therefore orthoisomer preferentially distilled over the para. So one can have this type of the separation. Now let us see how this chloroform, though it is producing CCl2, how you got this aldehyde group, how this CCl2 is produced, how it is, what is the method of calling this CCl2 and all that we will see in the mechanism of this Riemann-Tiemann reaction. Let us see the mechanism of Riemann-Tiemann reaction. RTR stands for the Riemann-Tiemann reaction. Just now we have seen. Skeleton reaction, once again I will write, that is phenol when treated with the chloroform CHCl3 and KOH, we are getting an orthoisomer of introducing the CHO into the phenol plus its para isomer also will be formed, a mixture is formed. How this aldehyde group, that is called formaldehyde group, coming is called as a formaldehyde coming, isn't it? Just like chlorination, chlorine coming is called chlorination. So this is formaldehyde coming. So I call this reaction as a formylation. Formaldehyde coming is called formylation, specifically phenol formylation. So Riemann-Tiemann reaction is nothing but a phenol formylation. How this formylation taking place? Let us see the mechanism. First, chloroform reacts. The chloroform has got 3 chlorines and the K, isn't it, 1 hydrogen. So KOH is reacting. OH minus will take away the H plus, right? This is a base. So it pull out the H because all the chlorines are pulling. So the H will have some acidic nature. Therefore OH is readily able to pull this hydrogen, leaving the minus charge on the carbon. So what you get immediately is a C with minus with the chlorines. You can call this one as a trichloromethyl carbanion with plus sign minus water is formed. In the first stroke, what you will get is CCl3 minus is formed. Now the K plus will take away the one Cl with 2 electrons minus of Cl minus plus K forms into KCl plus sign minus salt is. This becomes into a one side minus already there, the other side 2 electrons are gone. So literally you will get this type of compounds, that is 2 chlorines containing a cation and as well as anion on the same carbon. Obviously writing like this it's not correct, fair, because element containing plus sign minus simultaneously is not correct. Instead what we write is, you write like this, 2 chlorines, a minus charge is shown with a lone pair and a plus charge is shown with a vacant orbital. So now we have a carbon with 2 chlorines with a lone pair and the vacant orbital. This will have the, in fact, sp2 hybridization with the electronic configuration 1s2, 2s2, 2p x1, 2p y1, 2p z0. That is, one electron is removed. So therefore the last orbital is 0. One excess electron is in the s2. So these two undergoes sp2 hybridization, having the 3 hybrid orbitals, 3 sides, 3 is formed. Out of that, one will have a pair. The other 2 are making the sigma bonds with the chlorine. So this is sp2 hybridized. One unpaired, that is 2pz will be there. This will have a, that is a vacant orbital with no electrons, 2pz, 0 vacant orbital is there, working as a electron receiving capability showing. So therefore it is called as an electrophile. In fact, a lone pair can also donate as a nucleophile, however, but right now in this reaction the CCl2 with a dot to pair and a box, you can write like this. Both are in the same orbital, so you can write like this. Leave the vacant orbital, CCl2, I'm sorry. So CCl2 you can write. This is called a dichlorocarbene. Dichlorocarbene, or specifically you can say it is a singlet. Singlet dichloromethylene carbene. Why methylene means CH2 is called methylene. In the methylene that carbene is there, so singlet dichloromethylene carbene is the total nomenclature. Now let us see how the reaction is proceeding. In the first you take phenol. The phenol in basic medium with KOH, show its salt, that is a O minus and 2-3 bonds, because the OH minus takes away the H plus. So what you will get is a potassium salt of phenoxide is formed. Now this lone pair you show and the double bond is polarized, so that you will get a double bond with a minus charge with 1 hydrogen and 2 bonds. This is called what? Ortho negative charge containing phenoxide anion resonance structure. One of the resonance structure of this is called phenoxide. Phenol exists as a phenoxide anion in the basic medium. The phenoxide anion, one of the resonance structure is ortho minus. Now this CCl2, using the vacant orbital, it is attacking. Using the vacant orbital, it is attacking on the pair of this ortho minus. So therefore a bond is formed between the ortho carbon and the CCl2, right? So this lone pair now comes as a minus charge. So there is 1 hydrogen, so there is a double bond O. In fact, you can open it and show minus and plus is there, that is the intermediate of the species. Now you drop this hydrogen and the 2 electrons will come here, the double bond will be given back, will become O minus. So this hydrogen may go here, but it prefers to go onto the carbon. So what you get next structure is a carbon with the hydrogen and the 2 Cls, again double bond is created. This will become into O minus. So phenoxide with dichloro with methyl group is formed. Because of the basic medium, strong base is there, 2 Cls will go hydrolyzed to become the 2 OHs. So subsequently you will get a 2 OHs containing methyl group is formed with on a phenoxide. Now the 2 OHs are unstable, so water molecule is eliminated, you get an aldehyde. So finally you got a now answer. What is group introduced is CCl2, but is hydrolyzed to become into the 2 hydroxy groups, and elimination of water, minus of water, will give the aldehyde function, but a phenoxide anion is there. Now as long as you maintain the KOH medium, you will have a basic, that is salt, potassium salt of phenoxide will be the answer. But when you acidified at the end, either with water and acid or dilute acid, I will say. So with this acidification you get the final answer, that is a phenol containing aldehyde group at ortho. Similarly, if the CCl4 attacks, if this minus is given, this goes to minus on the para. So next resonance structure of this one will be the para minus will be there. On that para minus, if CCl2 attacks, you will get the para isomer, that is the aldehyde group can be at para also. How you get this para aldehyde means that is what you have to explain. If the minus is at para, if this minus goes to para, then CCl2 can attack at para. So para aldehyde also you may get, ortho aldehyde also group can be, both mixture will be, ortho and para mixture will be formed. Only the ortho one has a specific name called a salicyl aldehyde is given for only ortho. Para has no specific name, you have to call by the hydroxy benzaldehyde or formyl containing phenol, right? So in this mechanism what we have to observe is, first how this electrophile is generated from the chloroform. First CCl3 minus and then it will become into CCl2. It is called a carbene holding a pair of electrons and vacant orbital. Vacant orbital is 2pz0. Pair is in the sp2 hybridized. These 3 are hybridized to sp2. This is a hybridized sp2 hybridized orbital. The pair is there in sp2 hybridization. So, if somebody asks what is the angle between these two chlorines of dichlorocarbene singlet, it is 120 degrees roughly, because this pair may have slight expansion and these two chlorines may come light closure also. The sp2 hybridization will have closer to the 120 degrees. So, and that comes as an electrophile, and subsequently you will get the salicylaldehyde formation. The chloroform also gives one more important reaction, which is called a carbyl amine reaction. Carbyl amine reaction. Popularly, you can call it as a CAR. So, the reaction is very much important in the differentiating type of the reactions also. Like for example, the reaction takes place on the aniline, amino containing benzene. This is called aniline. Amino benzene or aniline. The aniline reacts with chloroform CHCl3 with the KOH or NaOH. See here one common reagent, that is chloroform and KOH. Previously also we have seen in the with the phenol. This is with aniline. Aniline, chloroform, KOH on heating, the NH2 converts into NC. Called phenyl isocyanide. Phenyl isocyanide. This is radical function. Function is isocyanide. So, phenyl isocyanide. The same thing is also called phenyl carbyl amine. This is IUPAC nomenclature in fact. Phenyl carbyl amine is IUPAC nomenclature. The K will become into KCl. K will become into KCl, and if you take 3 KOH, 3K and 3Cl, 3KCl is formed. 3OH and here 1OH, here 2H, 3H2O is formed. What remains is the carbon of the chloroform and the N of the aniline becomes into NC. It is a balanced equation, however, but it is not that simple. In this case also, these two will generate the CCl2, that is a vacant orbital and a lone pair containing species called dichlorocarbene will be the attacking species as an electrophile, but it is not attacking on this, it is attacking on the nitrogen. Therefore, this type of the compound is formed. The mechanism is also that it's not that difficult. Relatively, when compared with the Reimer reaction, it is somewhat simple. The first step is common, that is how you get CCl2 means first CHCl3 with KOH, the OH minus and H plus goes and you will get CCl2, CCl3 minus, right, minus of water. And then from here the K plus will take away the 1Cl minus, forms into KCl, and the CCl2 with lone pair and vacant orbital is known as dichlorocarbene singlet, dichloromethylene carbene, you can say totally singlet dichloromethylene carbene. A carbene, just like a carbocation, carbanion, it is one of the intermediate, is having the sp2 hybridization. This is a hybrid orbital with the two chlorines, one hybrid orbital, two hybrid orbitals, and this is another hybrid orbital, and singlet dichloromethylene carbene it is known as. This is attacking on the amino group. So, let us see a small or one or two step mechanism. On the aniline, the aniline can show a resonance structures. You can have a resonance structure like this, have a minus sign, minus sign, minus, but the CCl2 prefers to attacks on the nitrogen instead of the minus charges of the benzene. So, this is a with vacant orbital it is attacking on this one, or the minus attacks on this vice versa is also more correct, because many mechanisms are shown with an arrow, say with a curved arrow means movement of electrons. So let us show the lone pair is attacking on the vacant orbital, so therefore a direct bond between the nitrogen and the carbon is developed. Here we have two chlorines with a minus charge on this one, and with the two hydrogens lone pair is lost, a plus charge is formed. So you can have now the two slight different variation in the mechanism. You can directly, you can say 2 H's, 2 Cl's are going out as a 2 moles of HCl, because of KOH is there, isn't it? Because of KOH is there, a strong base will take away the 2 moles of HCl. Straight away you can write N with the triple bond with a benzene. This structure you can directly, you can write 2 HCl, HCl, twice you eliminate, you will get it. Or first initially what happened, there is a minus and H is there, so the lone pair will be taken and H plus is shifted to this side. So what you will get is a neutral compound is maybe formed. N with hydrogen, a pair of electrons, and with C with the 2 Cl's and 1 H. This H is shifted here, a neutral structure is formed. Now from this again you get 1 HCl removal, H and Cl. 1 HCl is alpha, 1 HCl is beta elimination followed by alpha elimination. Again 2 moles of HCl will be removed to get back the same type of the compound. That is also another method of the explanation. But finally what you have to understand, very much important, is in the Reamer-Timer reaction the CCl2 is attacking on the nucleus, that is on the benzene ring, whereas here it is preferring to attack N. What makes difference means here this is nitrogen, that is oxygen. So when nitrogen and oxygen both, if you compare, the nitrogen is less electronegative, therefore more susceptible for the electron, that is donation. So this electrophile finds it is taking the electrons from the nitrogen is easy than in the case of phenol, O, that is oxygen. Oxygen holds the electrons more. So therefore here it is possible to attack on the nitrogen directly, and you are getting this type of the elimination. So you are getting finally carbyl amine. So this phenyl carbyl amine has one specific point to observe, the smell of this compound. This is very unique smell will be there. It is described as a bad smell. On the whole it is bad smell. But bad smell means not identical to all the bad smell, cannot be same, isn't it? So this will have some unusual type of smell. This smell can be only once you do this reaction. If the smell once you experience, the smell will be different, just like a jasmine good smell is different and a rose smell is different. So how you recognize a rose with the smell means directly like that. Here also this compound, whenever if somebody do this reaction, by doing the smell one can say yes, you are doing this a carbyl amine reaction, that is you are given an aniline and you are adding chloroform KOH and then smell comes, isn't it? So like that one can easily differentiate. For example, if somebody is having aniline and it's another isomer, so in the aniline we have a, let us say, methyl here, okay. So this compound also will give the phenyl, this methyl will be extra, but its isomer you have, okay, that is isomer means what, a CH, let us take a amino group on that methyl if it is there, okay. You have a NH instead of 2 hydrogens, you have a methyl. Now this type of, first this is called 1 degree amine, this is a 2 degree amine. Even 3 degree also will not respond for this reaction, only 1 degree. 1 degree, that too both aliphatic as well as aromatic. Both aliphatic, aromatic, 1 degree only will give this reaction. For 1 degree only, the removal of 2Cl, 2Ha is going to remove. So therefore only 1 degree, but it can be aliphatic or aromatic. So what we have taken is a 2 degree. So in the examination, for example, if this and this is given, how do you recognize which is which? Means for both you add chloroform KOH and boil it. The one which gives a carbyl amine is containing NH2, 1 degree amine. The other one is 2 degree. So like that 1 degree, 2 degree, or 1 degree, 3 degree if it is given, one can do this reaction. Once it was also asked in the IIT examination, a chloroform and CCl4. How do you give a test to differentiate these two? So, for both you add aniline, vice versa. For both you add aniline and KOH and heat it. So, for this if you add aniline I will write PHNH2 and KOH and heat it. What happens? Nothing happens. But in this case, if you add aniline and KOH, if you heat it, you get this bad smell, described sometimes as foul smell. Foul smell, that is somewhat rotten smell, you get it. So, this foul smell you get only in the case of the that is 1 degree, that is phenyl aniline, that is chloroform and aniline will give this foul smell, but CCl4 aniline will not give. So, therefore, in one case test will become success positive, the other case it is called negative test. So, CCl4 will give a negative the carbylamine test, CCl3 will give a positive carbylamine test, or 1 degree amine will give a positive carbylamine, 2 degree and 3 degree will give a negative carbylamine test. The test is not here by seeing the color or not by seeing the solid physical change, but it is the smell is the criteria. Quite a number of times the smell will be there, isn't it? Whenever sulfur containing compounds liberate H2S as a, isn't it? So, H2S will have a rotten sulfides will liberate the H2S gas when acid is added. Like that here, aliphatic, that is aliphatic as well as aromatic, 1 degree amines will liberate this carbylamines when chloroform KOH is added. So, this smell is very, very peculiar, and it is said that ppm level means 1 part out of million part. Ppm means parts per million, means in kilo 1000 milligrams, if you take million milligrams, 1 milligram if it is one this compound also will give a prominent smell. ppm level, that is called generally very dilute cases we describe that ppm levels. 1 part out of million parts, in 1 kilo 1 milligram is called a millionth part, isn't it? So, like that here also in a very small quantity, very dilute solution of this aniline also respond to this smell. Like that a small quantity of chloroform it is there, isn't it? If somebody is killed by applying the chloroform, a small part from the viscera is taken out and tested for the reaction. If that gives a bad smell of this particular bad smell, then one can see yes, the chloroform is used in this case. Yes, no, isn't it? That can be tested by the smell. So, smell is so peculiar and works in the very dilute condition ppm. So, therefore, the carbylamine reaction has become a very popular in differentiating the 1 degree amines versus secondary or tertiary, or chloroform versus CCl4. Both the cases you can use this test.